Hi guys, I am Shekhar from Sri Venkateshwara College of Engineering, studying in first year data science. Today I am here to explain about the topic of Introduction to C language. Structure of C programming. The structure of C programming generally follows a specific format. Here's a basic outline. Documentation section contains comments about the program, author, and other documentation details. Program to demonstrate the structure of C program. Author, your name, date, year, month, day. Preprocessor directives includes headers and macro definitions. As include stdio.h standard input output library. Global declarations, global variables, and function declarations. Int global variable equals to 0. Void sum function. Main function. The entry point of the program int main. Variable declarations. Int local variable equals to 10. Statements. Printf hello world /n. Return statement. Return 0. User defined functions. Definitions of other functions used in the program. Void sum function. Function implementation. Printf. This is a user defined function /n. Complete example. As include stdio.h global variable int global variable equals to 10. Function declaration. Void sum function int main. Local variable int local variable equals to 10. Output printf hello world /n. Documentation section. Preprocessor directives are link section. Global declaration section. Main function section. Declaration part, executable part. Subprogram section or user defined function section. Program to print a message. As include stdio.h main printf. This is C program /n. Quadratic equation program. As include stdio.h. As include math.h. Required for square root of function. Int main double a comma b comma c comma discriminant comma root 1 comma root 2 comma real part comma imaginary part. Input coefficients a comma b and c. Printf. Enter coefficients a comma b and c. Scanf percentage lf percentage lf comma ampersand a comma ampersand b comma ampersand c. Calculate the discriminant. Discriminant equals to b star b minus 4 star a star c. Check the nature of roots. If discriminant greater than 0, two distinct real roots. Root 1 equals to minus b square root of discriminant by 2 star a. Root 2 equals to minus b minus square root of discriminant by 2 star a. Printf. Roots are real and different /n. Printf. Root 1 equals to percentage dot to lf /n comma root 1. Printf. Root 2 equals to percentage dot to lf /n comma root 2. Else if discriminant equal to 0. 2 equal real roots. Root 1 equals to root 2 equals to minus b by 2 star a. Printf. Roots are real and the same /n. Printf. Root 1 equals to root 2 equals to percentage dot to lf by n comma root 1. Else complex roots. Real part equals to minus b by 2 star a. Imaginary part equals to square root of minus discriminant by 2 star a. Printf. Roots are complex and different by n. Printf. Root 1 equals to percentage to lf plus percentage to lfi /n comma root real part comma imaginary part. Printf. Root 2 equals to percentage dot to lf minus percentage dot to lfi /n comma real part comma imaginary part. Return 0. While loop. The while loop in C repeatedly executes a block of code as long as a specified condition is true. Syntax. While condition. Code to be executed. Example program. This example document states A while loop that prints numbers from 1 to 5. Hash include stdio.h. Int main. Int I equals to 1 initialization. While loop to print numbers from 1 to 5. While I less than or equals to 5. Printf percentage d slash n comma I plus plus increment return 0. Explanation. Initialization int I equals to 1 initializes the variable I. Condition. While I less than or equals to 5 checks if I is less than or equal to 5. Loop body. The code inside the loop printf percentage d slash n I is executed as long as the condition is true. Increment. I plus plus increments the value of I by 1 after each interaction. Termination. When I becomes 6, the condition I less than equal to 5 is false and the loop terminates. Output 1, 2, 3, 4, 5. Do while loop. In C, the do while loop is similar to the while loop but with one key differences. It guarantees that the loop body will execute at least once. Even if the condition is initially false, the condition is checked after the execution of the loop body. Syntax. Do. Code to be executed while condition. Example program. This example demonstrates a do while loop that prints number from 1 to 5. Hash include stdio.h. Int main. Int I equals to 1 initialization do while loop to print numbers from 1 to 5. Do. Printf percentage d slash n I plus plus increment. While I less than or equals to 5 condition return 0. Explanation. Initialization int I equals to 1 initializes the variable 1. Loop body. The code inside the do black printf percentage d slash n I is executed. Increment. I plus plus increments the value of I by 1 after each interaction. Condition. While I less than or equals to 5, check if I is less than or equals to 5 after the loop body executes. Termination. The loop terminates when I becomes 6, making the condition I less than or equals to 5 false. Output 1, 2, 3, 4, 5. Input and output statements. In C, input and output operations are typically handled using the scanf and printf functions, which are part of the stdio.h library. Input statement. Scanf. Scanf is used to read formatted input from the user. Syntax. Scanf. Format specifier, comma ampersand variable. Output statement. Printf. Printf is used to print formatted output to the console. Syntax. Printf. Format specifier, comma variable. Example program. This program reads an integer from the user and prints it. Hash include stdio.h. Int main. Int number. Input. Read an integer from the user. Printf. Enter an integer. Scanf. Percentage d, comma ampersand number. Output. Print the entered integer. Printf. You entered percentage d slash n, comma num. Return 0. Explanation. Hash include stdio.h includes the standard input output library. Int number declares an integer variable number. Printf. Enter an integer. Promotes the user to enter an integer. Scanf. Percentage d, comma ampersand number. Reads the entered integer and stored it in the variable number dot the and. Addresses of operator is used to provide the memory address of number. Printf. You entered percentage d slash n num. Prints the value of number. Common format specifiers. Percentage d integer, percentage f float, percentage d character, percentage s string. Call by reference function. Passing addresses swap ampersand a comma ampersand b passes the addresses of a and b to the function swap using pointers. The function swap uses pointers x and y to access and modify the original variables a and b. Differencing pointers. Inside swap, the pointers are differentiated to access and modify the values of original variables. Effect on original variables. The changes made to star x and star y inside the function reflect on a and b in main because the pointers refers to the memory addresses of a and b. Pointers. Pointers are a fundamental feature of C that allow you to store and manage the memory addresses of variables. Understanding pointers is crucial for dynamic memory management, working with arrays and handling functions efficiently. Key concepts of pointers. Pointer declaration. A pointer is declared using the symbol int star ptr. Declares a pointer to an integer. Pointer initialization. A pointer stores the addresses of a variable. You can use the addresses of operator ampersand to get the address of a variable. Int variable equals to 10. Int star ptr equals to ampersand variable. Ptr now holds the address of variable. Dereferencing a pointer. Dereferencing a pointer means accessing the value of the address stored in the pointer. This is done using the operator. The int value equals to star ptr. Value now holds the value of variable which is 10. Pointer and arrays. The name of an array acts as a pointer to its first element. Int array 3 equals to 1, 2, 3. Int star ptr equals to array. Ptr points to the first elements of array. Pointer arithmetic. You can perform arithmetic operations on pointers to navigate through memory. Ptr++ moves the pointer to the next integer, next memory location of size int. Example program. Hash include stdio.h int main. Int variable equals to 10. Int star ptr equals to ampersand variable. Pointer to variable. Output the value of variable using the pointer. Printf. Value of variable %d/n, comma star ptr. Output the address of variable. Printf. Address the variable %p/n, void star ampersand variable. Output the addresses stored in ptr. Printf. Addresses stored in ptr %p/n, void star ptr. Change the value of variable using the pointer. Star ptr equals to 20. Printf. New value of variable %d/n, comma variable. Return 0. Applications of pointers. Dynamic memory allocation. Use functions like malloc, calloc and free. Passing arguments by reference allows functions to modify the original variables. Handling arrays and strings. Easier and more efficient to pass pointers. Function pointers. Useful for callback functions and event driven programming. Thank you for watching my video.